In this video, we're going to look at solving a system of linear equations by substitution. In the previous video, we saw that a system of linear equations is two linear equations, and they can either be in the form y equals mx plus b, or in the form ax plus by equals c. Or they can just be able to be put into these forms. If you're able to put an equation into one of these forms, it's a linear equation. But we'll look at systems of two of these equations, and we're going to solve by substitution. The idea is to solve one of the equations for a variable and then plug it into the other equation. Here's our example. We have 3x minus 6y equals 3 and 4x minus 3y equals 14. So I broke down the process into steps here. Step 1 is pick an equation and a variable to solve for. So I'm just going to go ahead and pick the first equation. I have 3x minus 6y equals 3, and I want to go ahead and solve for x. You could pick either equation and either variable. So I'll take my 3x minus 6y equals 3, and I chose to solve for x. So what I want to do is get x by itself on one side of the equation. So I'll start by adding the 6y to the other side of the equation. And I end up with 3x equals 3 plus 6y. Now I have to go ahead and get the x by itself. I don't want that 3 attached to it, so I'm going to divide both sides by 3. So I divide by 3 over here, and I divide by 3 on the right-hand side. And so what happens is now the x is by itself with no coefficient written in front. And I have x equals 3 over 3 plus 6y over 3. And I can go ahead and simplify that. So I get x equals 1 plus 2y. Now I have the first equation solved for x, and I'm going to substitute that variable into the other equation. So my other equation is 4x minus 3y equals 14. And I'm taking this x equals 1 plus 2y, and I'm putting it in for the x in this equation. And so what I end up with is 4 parentheses. I'm going to write 1 plus 2y instead of x, and then minus 3y equals 14. So I substituted that x equals 1 plus 2y into the second equation. Your third step is to solve for the values of the variables. So I'm going to take the equation that I have here. I have 4 times 1 plus 2y minus 3y equals 14. I'll go ahead and distribute. So I get 4 plus 8y minus 3y equals 14. Combine your like terms here. So we have 4 plus 5y equals 14. Subtract 4 from both sides. So we get 5y equals 14 minus 4 is 10. Divide both sides by 2. So we get, divide both sides by 5 is what I meant. If I divide both sides by 5, then I get y equals 2. And now from step 1, I know that x equals 1 plus 2y. So x is going to equal 1 plus 2 times 2. So x equals 5. So my solution as an ordered pair is going to be 5, 2. I always list the x first when I'm doing an ordered pair. So that's my solution to the system. And now I want to check it. So remember, to check, we plug a point into our original equations. So I have 3x minus 6y equals 3. Let me write that down here. 3x minus 6y equals 3. And I have 4x minus 3y equals 14. So to check, I've written down both of my original equations, and I'm going to go ahead and plug in 5 for x and 2 for y. So I'll have 3 times 5 minus 6 times 2 equals 3. And that's 15 minus 12 equals 3. So that one checks out. Now I have 4x minus 3y equals 14. So I'll do 4 times 5 minus 3 times 2 equals 14. 4 times 5 is 20. 3 times 2 is 6. So 20 minus 6 equals 14. That one's true also. So I know that this is the correct solution. 5, 2, or x equals 5, y equals 2. Now you can also check using Desmos. If you pull up the graphing calculator and put in your two equations, I'm going to type in 3x minus 6y equals 3. And I'll type in 4x minus 3y equals 14. If I look at where the two lines cross, they cross when x equals 5 and y equals 2. So you can check your answer by graphing the two equations in Desmos. However, on the test, you will have to show your work in order to earn credit. So don't just plug them into Desmos first. Do the work first, do all of these steps first, and then check your answer in Desmos. So this was solving by substitution. Just a reminder of the steps. Pick an equation and a variable to solve for. Substitute that variable into the other equation. Solve for the values of the variables, and then check the answer in the original equations.